Okay, so we're wanting to graph a logarithm. How do you graph a logarithm? Well, let me give you some important information. So basically, I would just make a table, kind of like I did for exponential graphs. And remember, just like for exponential graphs, I encourage you to plug in as your first point, start with an x. Let me put it this way. Start with an x that makes the inside of the parentheses equal 0. So remember, for exponential graphs, we had things like y equals 3 to the x minus 7 plus 10 or whatever. And I would say plug in plus 7 because that'll make the power 0. So remember, for exponential graphs, we always started by plugging in whatever would make the power 0. Remember that for you right here. Let me grab the notes, the exam 3 notes, and take a look at that. See if I can find that. So for graphing exponentials, where was it? There, graphing exponential. Plug-in that makes the power 0. Yeah, so there it is right there. So let me add it in right here and paste it in so you can see it. There it is. So back when we graphed exponentials, make a table and first plug in an x value that will make the power 0, right? Well, now for logs, it's very similar. I'm going to start with an x value that makes the inside of the parentheses 0. So that's same thing. Instead of the power, it's inside of the parentheses. So what's that going to be? What am I going to plug in right there that'll make the inside of the parentheses 0? Well, 2, right? 2. And so what are you going to get? Y equals log base 3 of 2 minus 2 plus 4. So that's y equals log base 3 of 0. We made it that way on purpose. Now, what is that? Well, let me tell you how you do logs on your calculator. So I need to help you with this. So let me give you that rule. Using the calculator, the log base A of B is the log of B over the log of A. Does that make sense right here? Let me write that again. It's the log of B over the log of A. So now I'm not proving that right now. Maybe I'll prove that a little bit later. But for now, let me just, I'll prove that later. Let me just say it's true. So basically, whichever one is lower down, that goes on the bottom. The higher one goes on the top. And you turn it into 2 logs. So for this right here, this is going to be the lower one goes on the bottom, the higher one goes on the top. So it's going to be log 3 log 0. Now, you might wonder, why are you doing this all semester? Well, because we don't have a log base 3 button on our calculator, do we? We only have regular log, which doesn't show its base on your calculator, which means 10. And you have ln, which means base e. Remember the 2 understood logs? The 2 logs that don't show their base, those are the 2 buttons on your calculator. Regular log not showing its base, which means base 10, and ln, which doesn't show its base, which means base e. So you don't have a log base 3 button. Some of the newer calculators do, but most of them don't have a log base 3 button, or all you have is base 10 and base e for natural log. So how do you do a log base 3 then? You turn it into 2 logs. Later, I will prove this is true. For now, I'm sure you trust me, this is true. The lower one goes in the bottom, the higher one goes in the top. We turn 1 log into 2 logs. It's called the change of base formula. Change of base formula. Again, I will prove it's true later. The lower down part has to go low down. So anyway, if you do that on your calculator, this is going to give you error. All this to say, when you hit log 0, it's going to go error. Now, what's up with that? That means there's a vertical asymptote there. So that means right here at 2, at x equals 2, there's a vertical asymptote. And that'll always happen when you make the inside of the parentheses 0. It's a good place to start. We need to. And then where do we go from there? Just add 1. Remember how we just add 1? Go to 3. And now let's plug that in. Come down here. I'll plug in 3. What are you going to get? Y equals log base 3 of 3 minus 2 plus 4. Remember how with the exponential, we would just add 1? Same thing here with the log. Just add 1. So you start with what makes the inside of the log, the parentheses 0. Then you just add 1. Now, what do you do? This is log base 3 of 1 plus 4. This is log of 1 over log of 3, isn't it? So, right, I just used the change of base formula there to turn 1 log into 2 logs. Hit the buttons on your calculator. This part will come out 0. 0 plus 4 is 4. So that's the point, over 3 up 4, right there. Over 3 up 4. Okay, now we need one more dot. We need one more dot. So we've got a vertical asymptote, and we've got one dot that's actually on the graph. So what do we do for our next dot? Well, what you could do is you could just add 1 again. I'll come up here and kind of erase this stuff. You could just add 1 again. It's not going to be a very nice point. Add 1 again, you go 4, and that'll be Y. Here, we change the color. Add 1 again, it'll be 4. So it'll be log base 3 of 4 minus 2 plus 4, Y equals. That'll be log base 3 of 2 plus 4. And then if you do that on your calculator, remember that the low one goes low, the base goes low. You'll get, here, I'll do it real quick. You'll get some decimal thing, 4 point something or other. Log 2 divided by log 3 plus 4. You get 4.63. And that's a fine point, but we can't do that on our graph, all right? You can't do 4.63 on your graph. So you need to keep going up. You need to go higher. So should we just add 1 again? Yeah, that'll actually work, just to add 1 again. You'll be at 5, and you'll get Y equals log base 3 of 5 minus 2 plus 4. Log base 3 of 3. Do that on your calculator. The lower one goes low, the high one goes high. You can probably figure that out. That's 1 plus 4 is 5. So that's 5. So that's 5, 5. That's the point 5, 5. Let me move this right here. 5, 5 is right there. So there's the point 5, 5. Now we've got 2 points. We can make our graph. And so if you click using the graphing tool, if you click on they want you to click on the vertical asymptote first. So you've got to click somewhere here, like at the 2, to make the vertical asymptote, and then click on the other 2 dots, and it'll make your log graph just like that. It'll go through these 2 dots, and it'll get close to the vertical asymptote line. So notice what I did. I started by plugging in, start with an x value that makes the inside of the parentheses 0. Move that out of here. So that's very important. That's the most important thing. Start with an x that makes the inside of the parentheses equal 0. So right there. So I plugged in 2 because that made the inside of the parentheses 0. And that will give you your vertical asymptote line, because it'll be an error on your calculator. So that's your VA. That's your vertical asymptote line. And you have to click on that first. That's at 2. And then just add 1. Plug in 3. I got 4. When I worked it out. And then I just kept adding 1. I got a decimal, 4.63. So I added 1 again, plugged in 5, and that came out clean. So just keep adding 1 until you come out with another clean whole number spot. Click those two dots and it makes the graph. What's the domain? Remember, domain is the left edge, right? Which left edge? 2 to infinity. So parenthesis 2 to, why parenthesis? It doesn't touch the 2. See how the graph gets closer and closer and closer to 2, but it never touches it. So this is a parenthesis 2 to infinity. What is the range of this graph? Remember, the range is the vertical coverage, the up and down on the y-axis. So the bottom is negative infinity, the top is, oops, it's scribbly, positive infinity. So the range is negative infinity to positive. The graph goes down forever, up forever. And the asymptote, that's x equals 2. We see it right there on the graph, x equals 2. So there we go.